Hey guys, welcome to our YouTube channel. So in today's video we are going to discuss about the code smells and the problem of the code smell. The agenda of today video is what is the code smell and the common type of the code smells, side effect and the best practice to remove the code smells. So without wasting any time, let's begin it. So let's start from the code smell definition. A code smell is a problem in your source code. That is not a bug actually, but it is technically incorrect. Like if we talk, your code will still compile and work as expected, but there is some technical glitch and like your code is not following the software design principles. That may lead a problem in future. Let's take an example like duplicate code that was copy paste in several places uh, like in your software there is some functionality which is required at the multiple places, but instead of you keeping it at one place and refer on the all other places, but you have copy paste the same logic at the multiple places in your application. What is the problem in this scenario? Like in future if you want to modify that logic and there is some changes are required, and so you need to do those changes at the all places where you have used the same logic, and it may increase the complexity of your application as well. So this is the one example of this code smell. In this scenario if you notice like your code will work as expected, there is no any compilation and execution issue, but technically it is not correct. The code smells are divided into multiple categories. So here we are going to discuss about some common code smell category. The first one is related to the duplicate code and logic. So as we discussed earlier, like your logic is duplicate at the multiple places in your application source code. And second one is the long method and the classes. Like in your application you have written some method to perform some logic, but that method has more than like 1,000 lines of code. So that is also considered as a code smell. In such scenario we need to refactor our long method. We need to divide that long method into multiple small method if it is possible. And the same scenario with the class, like class has the too many code, so we need to think about whether it is following the single responsibility and the drive principle. If it is not, then we need to refactor it properly. And the next one is the long parameter. Like this, sometimes we create a method which will take the arguments. So arguments are the limited number, 2 arguments, 3 arguments, 4 arguments methods. But if it is going beyond this 5 6 arguments, then we need to think about it. Like we can we pass the more parameter to this method, or we can create a class or structure accordingly to pass those parameters into a as a object type. So that is also another code smell type. Next one is the code comments. Generally we write comment into our source code, but some developer or expert says that that is not good. Like your code must speak itself. Commenting is required, but not at all places. Like the at the abstract level, when you are creating any documentation and when you are creating any interface methods and such scenario, you can write some brief discussion about that the abstract method, what we are going to achieve using this method. But inside your concrete implementation there is no need to add any comments on the top of the method, even inside the method. That is the big problem. Sometimes we write some logic at inside our function and we wrote some comment there, like this line is doing this and this line is doing this. So that is not good. That is also considered as a code smell. So next one is divergent changes. So divergent changes happen when a class takes one or more functionality, like it is not following the single responsibility principle, like it is doing the multiple things. So that is considered also a code smell, because it will hurt code readability and reusability. The next one is shotgun. Shotgun is the little, you can say, the opposite of divergent changes functionality. So it is a functionality that is spread out across multiple components. So making one change making one change require changes on the multiple locations. So like you are using, means your modules are divided into multiple source files, and some logic is common in almost all files. So in this scenario you need to modify the logic, like if there is any changes required, then you need to modify that logic on the multiple places as well. So that is also considered as a core smell. So here are some major or the common core smell, but there are other core smells category as well. So as we discussed earlier as well, the code smell doesn't have any direct side effect, means your code will compile and execute as expected, but there are some indirect side effect on your project or your software. So the first one is it will increase your maintenance cost and the time. Like as we discussed earlier, if the same logic is written at the multiple places and your class is not following the single responsibility and other single responsibility dry and solid principles. So in this scenario, if in future you are going to add any additional feature, or you are there is some bug which you want to fix it, in this scenario you need to modify the code at the multiple places. It will definitely increase the developer time, also it will increase the QA time, and indirectly it will impact the cost of the software development as well. The second one is also similar to the same thing. It will increase the project complexity, like if the same logic is written at the multiple places, and it will increase the source code size of your software or your application, and it also make your code more complex in future. If there is any bug or feature you want to fix it or add into your application, in that scenario it is quite difficult to understand the logic and to make changes into the existing code. So these are the some common side effects of the code smells. We can remove these code smells by following some best practices. Here are the some common best practices which we can follow during our software development. The first one is the use modern IDE. The IDEs are come with the integrated static code analyzer and the AI, which will help to refactor your source code and the variables name and other things. And second is the test first. The test first is whatever logic you are going to written in your software code, you must write a test case uh, which tests that logic at least. Next one is the small discrete changes, like if you are working on any exist application where is lot of code smells, so try to resolve them in chunks, like first fix the small part, then move on the next part and test it, then move on the next part. And next one is do not afraid to rewrite the code. So based on the current code smell, there may be a chance like we need to rewrite the complete logic again. So do not afraid in such scenario as well. And the next one is the important one, the use static code analyzer tools like the sonar cloud or sonar cube, which help to fix this, not only this code smells but some additionally problem like vulnerabilities, hotspots, and any security leakage of your application. So if you want to make your application more robust, then you can integrate such type of static code analyzer tools which help to resolve, yes, multiple issue into your source code. So in upcoming video we are going to discuss about the sonar cloud and their static code analyzing rules with the C# programming language. So hope so guys this will help you. Thank you guys. Thank you to watch it. We will meet again in the next video. Bye.